Lesson 94, solving multi-step absolute value equations. The very first thing you need to know is you want to isolate the absolute value. You've got to get that all by itself on one side before you can finish solving. So these are equations, which means there's an equal sign. Here's an example. We have the absolute value of x divided by 2 minus 1 equals 14. So to isolate the absolute value, we need to do inverse operations. We're going to add 1 to each side of the equal sign, and we get the absolute value of x divided by 2 equals 15. Then we have to do the inverse of divide by 2, which means times both sides by 2. We get absolute value of x equals 30. Now, the absolute value is isolated, so to solve this, we're going to have two answers. We're going to have negative 30 and 30. Those are both 30 units away from 0. And then if we want to graph our answer, we're going to draw a number line. We'll have 0, maybe count by 15. So negative 15, negative 30, 15, 30. And since it's just two numbers, all you do is just plot the two dots at 30 and negative 30. Here's another example, example 2. So we have negative 3 times the absolute value of x minus 10 equals negative 5. So again, we're going to do inverse operations. We'll start by adding 10 to negative 5 and negative 10. We get the absolute value of negative 3 times the absolute value of x equals positive 5. We're going to divide by a negative 3. And we get the absolute value of x equals negative 5/3. Now, absolute values are always positive. So we can't get a negative 5/3. There's no graph. And the solution is the null set. Okay, another example, example 3. We have 2 absolute value of x divided by 3 plus 9 equals 11. Inverse operations again, so we're going to subtract 9. We get 2 absolute value of x divided by 3 equals 2. Now we're multiplying by a fraction, so if we multiply by the reciprocal, we'll be able to get the absolute value of x all by itself. The 2's can cancel, and we get the absolute value of x is 3. So the solution is negative 3 and 3, and if we're to graph it, we just want to make sure that we put dots there on negative 3 and 3. And I'm going to do another example, example 4. We have 2, the absolute value of x minus 4, and your absolute value plus 10 equals 30. So we're going to subtract 10 from both sides. We get 2 absolute value of x minus 4, and your absolute value equals 20. Then we want to divide both sides by 2, divide the whole side by 2, and we get the absolute value of x minus 4 equals 10. Now we want the x minus 4 has to equal negative 10, or x minus 4 equals 10. If you have a negative 10 inside the absolute value, then that answer will be 10. If you have a 10 inside there, the absolute value will be 10. So we set what's inside equals negative 10 and 10. So I'm going to add 4, and I get x equals negative 6, or and here I'm going to add 4, x equals 14. So to write the solution, we can put x equals, in braces, negative 6, comma 14, end your braces. Then to graph, we have a negative 6 here and a positive 14, and we put our dots right there. So now it's graphed. Okay, one more example. We have example 5. 3 the absolute value of x divided by 2 minus 1, and your absolute value equals 18. We have to get the absolute value all by itself. So just these two lines by itself, so we're going to divide both sides by 3. We get the absolute value of x divided by 2 minus 1 equals 6. Then what's inside the absolute value has to equal negative 6 or 6. So we take out the absolute value signs and we rewrite it as two equations. Now we need to solve for x in both of those. So we start by adding 1 to negative 6 and negative 1. We get x divided by 2 equals negative 5. And then we're going to times both sides by 2, and we get x equals negative 10. Or, then over here we're going to add 1 to 6, and we get 7. So x divided by 2 equals 7. Multiply both sides by 2. So x equals 14. And then we put that in braces, negative 10, 14. And if we wanted to graph it, we would just put dots on the number line at those points. And that's the end of the lesson.